Factorizing the sum and difference of cubes. Right, now when I talk about the sum and difference of cubes, I have a basic rule, same as with the difference of squares, that I need to know. And if you don't know these equations, please write them down somewhere where you can see them a few times daily. Write them down, stick them on your cupboard, or write them down, take a picture and make it your phone's background. Somewhere where you can see these equations daily until you know them. So if I have the difference of two cubed numbers, I take in the first bracket the difference of the cube roots of these numbers, and then in the second bracket I will square this first one, square the last one, and multiply these two terms in the first bracket with one another for my middle term. And then my signs usually, not usually, always have the same sign here and here, and then a different sign here, and then the last one you will see in both instances are always plus. So if I have the sum of two cubes, I have the sum of x and y there in the first bracket, and then for the second bracket I square the first one there, I square the last one, and this is a plus, so that's a minus, and the last one is always a plus. Alright, now first get to know these, and if you know them we can look at a few problems to see how we are going to apply these rules in the real life or in real problems. So say for instance I have 8x cubed minus 125. Now how I want to factorize this, I immediately see this. I can't take out the highest common factor. This is a cubed number, a cubed number, and a cubed number, and I get first for the first bracket the cube root of 8 is 2, the cube root of x to the power of 3 is x, and the cube root of 125 is 5. Now for my second bracket, I'm first just going to fill in the terms and then the signs. For the second bracket, I square this first term, which is 4x squared. I put that here. I square this term, 5 squared is 25. I put this there, and I multiply these two terms with one another for my middle term. So this is 2x times 5 is 10x. And now for my signs. My signs are the same here in the question and in the first bracket, and then if this is a minus, this is a plus, and my second sign is always a plus, and I'm done. Now I feel like this is a trinomial and I want to even factorize this further, but with this rule you just fill in and you leave the second trinomial as it is. So let's see if I have 64a to the power of 3 b to the power of 6 minus 1. Now if you remember from difference of squares, if I have an even number exponent, to get the square root I just divide by 2. Now for cube roots I'm just going to divide by 3. The exponent, don't divide this number by 3, divide the exponent by 3. So the cube root of 64 is 4, the cube root of a cubed is a, and the cube root of b to the power of 6 is b squared. I just divide that by 3. And then the cube root of 1 is just 1. Alright, and now this is my first bracket. For my second bracket, I'm going to square this, square every single term. So I square the 4, the a, and the b squared, and that gives me 16a squared b to the power of 4, and I square the 1 for the last term, and for the middle term I just multiply these two terms with one another. So 1 times anything gives me that same thing, so the middle term is 4ab squared. Now if this is a minus, this is a plus, and the last one is always a plus. So say for instance I have x to the power of 12 plus 27. what I want to do is I get the, you see how I apply the rule, and that's what I do, and then I'm done factorizing. So for this one, I'm going to divide my exponent by 3, so 12 divided by 3 is 4, and the cube root of 27 is 3, and x to the power of 4 squared, I just double the exponent, so that will be 8, and 3 squared is 9, and I multiply these two for the middle term, giving me 3x to the power of 4. And then this is a plus, and then if this is a plus, this is a minus, and the last sign is always a plus. Quickly see what happens if it looks like a difference of cubed numbers, but 2 and 16 are not cubed numbers. But remember, I told you must always first check if I can take out a highest common factor. So if I can take out a highest common factor, do that first, and you will see if you do take out the highest common factor, I'm left with a difference of cubes, which I can go and factorize. I just keep the 2 there, don't throw it away, and then I factorize this into the cube root of y cubed is y, the cube root of 8 is 2, y squared and 2 squared comes in there, and 2 times y is 2y, and then this is a minus, so that is a plus, and this is always a plus. Alright, I just want to show you a very special example that something funny happens also. Say for instance I have x to the power of 9 plus 1 that I have to factorize. Now this is a cubed number, and this is because the exponent is divisible by 3, and 1 is a squared and a cubed and a fourth exponent number, because 1 times 1 times 1, doesn't matter how many times I do that, always stays 1. So 1 is a legit squared number, it's also a legit cubed number, and it's also a fourth exponent, etc. So I can get the cube root of x to the power of 9 by dividing the exponent by 3, giving me x to the power of 3 plus, and the cube root of 1 is 1. Then I'm going to square this and this, giving me x to the power of 6 and 1, and I multiply these with one another, x to the power of 3, and if this is a plus, this is a minus, that's a plus. But now carefully look at this first bracket. Can you see that this is still a sum of cubes? The second bracket I'm going to leave as it is, but the first bracket is going to become x plus 1, the cube root and the cube root, and then I'm going to make a second bracket with the squares and the product, and then this will look like this. And don't forget to carry over this second bracket and leave it just like that as it is. And now I'm done.